November 16th, 1951. The morning fog drifted slowly off Portsmouth Harbour, dissolving into the grey light as the silhouettes of warships emerged like ghosts from the mist. The damp air clung to uniforms and steel, the tang of salt and oil heavy on the wind. Captain Dennis Campbell climbed the gangway to HMS Illustrious, his gloved hand brushing the cold railing as he ascended. Each footstep echoed faintly on the metal deck, steady, deliberate, carrying the weight of a man who understood that every idea worth fighting for begins as something absurd. In his briefcase rested a single sheet of paper, a drawing so plain a schoolchild could have sketched it. A flight deck angled 10 degrees to port. No complex schematics, no equations, just a bold stroke of pencil lines that quietly defied decades of naval convention. It looked harmless, even naive, but Campbell knew the truth buried inside that sketch, that this unassuming idea might one day change everything. What he could not know, what no one in Portsmouth yet suspected, was that within 18 months this simple drawing would save more lives than any weapon system in naval history. For now, all Campbell felt was dread. He was a captain in a navy, losing men faster than it could train them. In the past 12 months alone, the Royal Navy had lost 43 aircraft to landing accidents, 43 machines torn apart, 17 pilots dead, dozens more maimed for life, all of them destroyed in the last 30 seconds of flight, the cruelest fraction of an aviator's career. The point where skill, courage, and training met the brute indifference of physics. When a 30-ton jet tried to hook a wire on a heaving steel deck at 140 miles per hour, the difference between life and death came down to inches. And behind the landing zone waited a steel barricade, stretched across the deck like a spider web of cable ready to stop any aircraft that missed or shred it. The Americans faced even grimmer numbers. In 1951 alone, the US Navy recorded 776 Class A mishaps accidents that ended in death or total aircraft loss. That was more than 2 per day, even in peacetime. The Korean War had amplified the carnage beyond reason. The USS Boxer reported 7 barrier crashes in a single deployment. The Princeton lost 9 aircraft in 4 weeks. Every pilot understood what missing the wires meant. You hit the barricade at full throttle or ploughed into the aircraft parked forward, igniting fuel and ammunition. One mistake could create an inferno that killed a dozen men before the fire crews could even move. The jet age had arrived like a thunderclap, but carrier aviation had not caught up with it. The new F-9F Panthers landed 40 knots faster than the propeller-driven Hellcats of the war years. Their engines took 7 full seconds to spool up from idle and eternity when you were dropping 20 feet per second toward the ocean. Landing signal officers stood on the carrier's port quarter, frantically waving paddles to guide the pilot in, but by the time a pilot recognized his approach was too steep, too shallow, or too fast, it was too late. Physics didn't care about signals. The future of flight had arrived, but it was killing its own pioneers. Every admiral, every engineer, every flight commander knew what they were facing. Jets were the future. But futures didn't matter when the present was slaughtering your pilots. Every solution tried so far had failed. What Campbell didn't know was that his impossible idea, this angled flight deck, would be mocked, dismissed, and nearly buried by the very men whose duty it was to prevent such tragedies. It would take persistence, defiance, and sheer moral outrage to force the world to see sense. The problem began 6 years earlier, in 1945, when Lieutenant Commander William P. Bill Rohn made the world's first jet landing on an aircraft carrier, the USS Wake Island. His FR-1 Fireball touched down at 90 knots, 20 faster than any piston fighter, and the arresting cables screamed as they took the load. It was a success, technically, but it was also a warning no one wanted to hear. The landing gear held, the cables held, but every man who witnessed it saw how narrow the margin had been. By 1950, the warning had become prophecy. Jet engines had revolutionized speed and altitude, but they came with a hidden curse: slow throttle response. Propeller aircraft could chop throttle on command, drop speed instantly, and land power off. Jets couldn't. They had to land power on, maintaining thrust through the approach because if they cut throttle and needed to go around, the engines wouldn't spool up fast enough to save them. Pilots now approached the carrier with their engines roaring, committed to landing with no easy way to abort. On a straight-deck carrier, there were 4 arresting wires stretched across 60 feet of deck. Beyond those wires stood the barricade steel cables designed to stop an aircraft that missed. Beyond that, rows of parked aircraft, fuel trucks, ammunition carts, everything that made a carrier a floating airbase. The arithmetic was merciless. A Panther touching down at 125 knots covered 211 feet per second. If a pilot missed the wires, he had barely 2 seconds before impact. When the barrier worked, it was violent but survivable. When it failed, it was mass death. Captain Bruce Williams, Air Operations Officer aboard USS Kearsarge, witnessed that horror firsthand in March 1951. The report he filed was clinical, but the memory never left him. Aircraft struck barrier at full power. Barrier separated. Aircraft continued forward into 6 parked Corsairs. Resulting fire reached aviation gasoline stores. 14 aircraft destroyed. 11 personnel killed, 23 injured. 2 days later, flight operations resumed as if nothing had happened. The Navy tried building better barriers. The British developed the flex deck, a rubberized surface designed to catch jets without wheels. Test pilot Lieutenant Commander Eric Winkle, Brown made 40 landings on it at Farnborough. He wrote in his report that it was fundamentally sound. To his friends, he called it bloody terrifying. The Americans spent millions on the Davis barrier, a mechanical web meant to stop a 25,000-pound aircraft at full throttle. It was impressive until it failed. Then it turned flight decks into crematoriums. The truth was undeniable. Stronger barriers couldn't prevent crashes. They just cleaned them up afterward. The problem wasn't the barrier. It was the deck itself. Captain William T. Razier of the Office of Naval Operations put it bluntly in a 1945 report. Current landing procedures force all aircraft into a 60-foot impact zone with 0 margin for error. This is incompatible with jet aircraft performance. In simpler words, we're trying to land 1,950 seconds aircraft on 1,940 seconds ships. Every engineer agreed something had to change, but none dared question the most sacred assumption of all. The flight deck must be parallel to the ship's axis. It had always been that way since the first carrier, HMS Argus, launched in 1918. The idea of altering it wasn't just heresy, it was madness. That madness, however, found its host in Captain Dennis Campbell. Campbell wasn't supposed to be the man who changed anything. Born in Southsea, England, in 1907, he joined the Royal Navy in 1925. He became a pilot in 1931, when naval aviation was still a gentleman's curiosity, canvas wings, open cockpits, and oil-stained goggles. He flew Fairey Swordfish torpedo bombers in the Second World War, slow, obsolete biplanes that somehow crippled the Bismarck. He wasn't a genius or an inventor. He was a professional who believed in doing his job. After the war, he was assigned to the Ministry of Supply, a bureaucratic post overseeing technical coordination between the Navy and civilian contractors. It was dull work, buried in requisitions and meeting minutes. He had no engineering degree, no laboratory, no staff of designers. But he had something rarer, a conscience that wouldn't stay quiet. In 1951, Campbell attended the funeral of Lieutenant Michael Mick Lithgow, a test pilot who died when his jet hit the barricade on HMS Implacable. Lithgow had been his student, 23 years old, newly married. His approach was flawless, his speed perfect. But he floated 6 feet too far, missed the wires, and met the barricade at full power. The barrier failed. The aircraft exploded. His widow was 5 months pregnant. Standing by that grave, Campbell told his deputy, Lieutenant Commander Nick Goodhart, "This is insane. We're murdering them with our own equipment." A pilot does everything right and still dies because 60 feet isn't enough margin for error. There has to be another way. Most men said such things at funerals and forgot them by the next week. Campbell didn't. He began collecting accident reports, talking to landing signal officers, sketching diagrams on napkins. He wasn't an engineer, but he could think like one. If you couldn't make the landing area longer, what if you made it wider? And if the ship couldn't be made wider, what if you changed the angle? The thought hit him one rainy night on a train from Portsmouth to London. He sat staring out at the blurred countryside, his pencil tracing lines across a notebook. If the landing deck were angled 10 degrees to port, a pilot who missed the wires wouldn't face the barricade. He'd fly over open sea, free to climb away and try again. No crashes, no fireballs, just air, water, and a second chance. He stared at the sketch for a long time, half convinced he'd drawn something idiotic. Either he'd found the answer, or he'd rediscovered why it was impossible. But the next morning he showed it to Goodhart. The younger man studied. It frowned, then looked up and said quietly, "It could work." On August 7th, 1951, Campbell carried his sketch into a meeting at the Ministry of Supply. Around the table sat some of the most senior figures in British naval aviation. Lewis Boddington, from the Royal Aircraft Establishment, Rear Admiral M.S. Slattery, Chief of Naval Research, and half a dozen engineers who'd spent their lives keeping pilots alive. Campbell laid his paper on the table and explained his idea. When he finished, the room erupted. "That's completely illegal," snapped Commander James, the Navy's senior flight operations specialist. "The International Air Navigation Convention requires all flight operations to align with the vessel's axis. What you're proposing violates maritime aviation law written after 15 years of operational experience. It's not innovation, Captain, it's nonsense." Campbell stood his ground, but the barrage continued. "You're asking pilots to land, across the ship's natural motion. Carriers roll and pitch around their keel. An angled deck means pilots will fight lateral drift with every landing. You'll make things worse, not better." The room quieted when Lewis Boddington spoke. "Show me the math." Campbell blinked. "I beg your pardon?" "The math," Boddington repeated evenly. "You say drift will be a problem. Prove it. An 8-degree deck on a vessel rolling 12 degrees calculate the drift differential over a 30-second approach." Silence filled the room. No one had the numbers. "Then we test it," Boddington said at last. "We'll paint an angled outline on HMS Triumph's flight deck and run simulated approaches. If the drift problem is real, we'll measure it. If it's theoretical, we'll know that too." Rear Admiral Slattery frowned. "You understand, Lewis, if pilots start crashing on that deck, you'll end your career and Captain Campbell's." "Noted, sir," Boddington said. "But if it works, we stop killing men who did everything right." That was enough. Within weeks, HMS Triumph left Portsmouth with a white outline painted diagonally across her flight deck. Not a structural change, just paint. For 3 weeks, Navy pilots flew touch-and-go runs, pretending the angled outline was the true landing area. The predicted drift never appeared. Pilots adapted within 2 landings. What they discovered instead was freedom. Lieutenant Peter Chilton, one of the test pilots, later wrote, "I came in high, missed the wires, and for the first time in my life, I wasn't terrified. I pushed the throttle and climbed away. No barrier, no panic, just another try. I felt like I'd been given my life back." By October, the tests proved it. The angled deck worked. The only question was whether anyone else would believe it. Because across the Atlantic, the US Navy faced the same crisis and the same pride. They had more carriers, more jets, and far more pilots dying. And they didn't like being told by the British that their designs were wrong. On September 14th, 1951, at the U.S. Naval Air Test Center in Patuxent River, Maryland, 40 American test pilots sat in a briefing room as Lieutenant Commander Eric Winkle, Brown Britain's chief test pilot, prepared to speak. He was a legend, the man who'd landed more aircraft types on more carriers than anyone in history. But that didn't matter here. Every man in the room was calculating whether to trust him. Brown began simply. "Gentlemen, in the past year, how many of you have hit the barricade?" 7 hands went up, then 12, then 15. "How many of you have lost a friend to one?" Every hand. Brown opened his briefcase, took out Campbell's drawing, and pinned it to the wall. "This is what we've been testing on HMS Triumph. It's going to sound insane, but I've made 63 landings on it. I'm alive because of it. So, hear me. Out." The room exploded in disbelief. "You want us to land sideways?" One pilot barked. "The LSO won't even see our approach." "What about the island?" "You'll have us flying into it." "You'll kill more men than you save." Brown waited for the shouting to die. Then he said, "Every objection you just raised, we had them all. Then we tested it, and we found this. When you miss the wires on an angled deck, you don't die. You just throttle up and go around." Commander Harold Buell stood, his face unreadable. "Commander Brown, I've been landing on carriers since 1943. You're asking us to throw away everything we know because a British captain drew a line on paper." "I'm asking you," Brown said, "to stop dying for a design flaw." The room went silent. "You're landing jets on straight decks because that's what you have," Brown continued. "But straight decks were built for Corsairs and Hellcats planes that could kill power and drop onto the deck. Jets can't. You're forcing 1,952 aircraft into 1,942 doctrine. The angled deck doesn't break the rules, it makes the rules match reality." Rear Admiral Apollo Susek, the senior US Navy aviator in London, spoke next. "I've observed the Triumph tests. The concept works. I've recommended trials aboard USS Midway." Rear Admiral Alfred Pride, head of the Bureau of Aeronautics, shook his head. "We're already testing solutions. The Davis barrier has a 98.7% success rate." "Of the aircraft that hit it," Brown countered, "what about the pilots who see it coming and ditch instead? Your statistic measures metal, not lives." Silence again. Then Susek said firmly, "We'll test it. Paint trials first on Midway. If it works, we refit one carrier. If it fails, we bury it. But we test it." The room nodded. Pride glared, but agreed. The meeting ended, and Brown packed his briefcase, wondering if he'd just ended his career or saved thousands. He didn't know yet that within 90 days, the painted line on Midway would prove flawless. The US Navy would retrofit the USS Antietam into the first true angled deck carrier in the world. And when the first pilot landed there, everything would change. The sea below looked calm from altitude, a thin sheen of glass spread across the horizon. But Thatch knew how deceptive that quiet could be. Below that calm surface were survivors, wrecks, and memories buried in salt. The radio crackled again with voices from the other squadrons, men scattered across miles of airspace, each fighting their own invisible war. Thatch levelled off at 12,000 feet, scanning for any sign of enemy movement. The sun was behind them now, and he used it like a shield, flying into its glare so any approaching Zeros would be blinded if they came from that direction. Down below, the smoke over Wake Island rose like a wound in the Pacific. The garrison was still fighting. Radio intercepts suggested the Japanese had landed troops again the night before, but the defenders were holding. Every sortie Thatch flew now was not just about the tactical gain of destroying enemy planes, it was about time, giving Wake's defenders a few more hours before the inevitable overwhelmed them. He checked his fuel again. Enough for another 20 minutes before they had to head back to the carrier. He thought of his pilots' young men, most of them with barely 50 hours in the air. They looked to him not only for orders but for calm. He gave them both, even when he didn't feel either. "Blue leader to all Wildcats. We're heading west to intercept. Maintain altitude. Don't climb until I say." They acknowledged. The formation spread slightly, not by accident but instinct. They trusted each other now. That kind of trust only came after you'd seen one of your own fall and still had to keep flying. At 7:52 a.m., radar picked up a new wave of incoming bogies, 15 at least. The Japanese were sending everything they had to finish off the remaining defences. Thatch's flight adjusted course. When the silhouettes appeared on the horizon, Thatch immediately recognised the discipline of their formation. Zeros again. They moved like water, smooth, disciplined, deliberate. He knew what was coming. He'd studied their patterns, how they turned tighter, how they used the vertical dive to exploit the Wildcats' slower climb. The only way to counter that was to turn their own aggression against them. Execute beam defense. We're splitting pairs. Charlie section, follow me. He banked hard left, the G-force pressing against his ribs, and saw the others respond instantly. The Zeros took the bait, peeling off to chase. The trap was set. It happened fast. 1 Zero dove after Thatch's wingman, guns flashing, tracer fire slicing through the air. Thatch rolled inverted, pulled back, and came down behind the attacker. His timing was perfect. The reticle crossed the Zero's fuselage, and he fired a short burst. The enemy plane shuddered, a puff of smoke bursting from its wing root before it spiraled down. "Good hit," his wingman called. "Keep your speed up. Don't get dragged down." 2 more Zeros approached head-on. Thatch and his wingman executed the maneuver he'd been perfecting, the weave. Both planes crossed paths, then turned sharply toward each other, forcing the attackers into a deadly crisscross zone. 1 Zero overshot and was caught in the intersecting line of fire. It went up in flames before it could climb away. For the next 6 minutes, the sky was chaos. The radio was a blur of shouts, gunfire, and strained breathing. Thatch's hands moved instinctively over the controls, not thinking, only reacting. He had no time for fear. Then, it was over. The enemy survivors broke away, heading north. The Wildcats regrouped, battered but intact. 2 of his men were hit, one with a smoking engine, limping back toward the sea. Thatch checked his ammunition half gone. He could stay and chase or escort his wounded pilot home. The choice wasn't even a question. "Form up, we're heading back." They flew low on the return leg, engines humming steadily over the calm expanse of ocean. The carrier USS Lexington was a dark streak in the water ahead. Thatch could already see the smoke trailing from one of the destroyers, screening her a hit from the earlier raids. He adjusted formation and began descent procedures. On deck, the crew was already scrambling to prepare for another strike. Planes were being rearmed and refueled with mechanical precision. The smell of gasoline and oil mixed with salt and cordite. Thatch's boots hit the deck, and before the propeller had even stopped spinning, he was surrounded by maintenance crews pulling panels, checking rounds, wiping down gun barrels. He climbed down, pulled off his helmet, and walked straight to the air operations table. Maps were spread everywhere, circles and lines showing flight paths and contact reports. The Admiral looked up briefly, eyes bloodshot. "How'd it go?" 5 confirmed, Thatch said. 2 more probable. We lost none. There was a flicker of something in the Admiral's expression, a relief so brief it almost didn't exist. "You'll fly again in 20 minutes. Enemy bombers coming in from the northwest." Thatch nodded. There was no time to rest. He grabbed a cup of coffee, black, lukewarm, tasted like metal, and stepped back out onto the deck. His crew was already halfway through refueling his Wildcat. He looked out over the ocean again. The sky was clearing, sunlight cutting through the clouds, glinting off the water. Somewhere out there were more Zeros, more pilots just like him, waiting to clash in the same sky. He thought of his wife, back in California, the letter she'd written that he kept folded in his breast pocket. He'd read it a dozen times, every word now memorized. It talked about the garden, the neighbors, the radio reports. She told him to come home safe. He smiled faintly at the thought. The call came over the loudspeaker, another scramble. Thatch climbed back into his cockpit, fingers wrapping around the throttle as naturally as breathing. The Wildcat's engine roared to life, vibrating through the steel deck. As he waited for the launch signal, he glanced at the flight roster pinned to his leg clipboard. Half the names were men younger than 22. He'd once been like them, full of certainty that war was a test of skill, not endurance. But skill only carried you so far. The signalman waved his flag. Thatch saluted, shoved the throttle forward, and was thrown back into his seat as the catapult hurled him into the air once more. Below, the carrier shrank to a grey sliver in the endless Pacific. Ahead lay clouds, sunlight, and the distant shape of the enemy. The sky was still theirs to fight for. He adjusted his trim, checked formation, and climbed toward the horizon. Every mission now was another gamble, another chance to outthink and outlast. Somewhere in the distance, faint but growing clearer, the black specks of new planes began to form against the morning light. Thatch breathed once, steady and deep, and spoke into the radio with a calm that came only from repetition. "Blue leader to all Wildcats," he said. "Let's get to work." The squadron banked together, rising into the blinding glare of the sun. The sound of engines merged into one continuous roar that filled the air, rolling across the vast ocean below as they vanished into the light warriors flying toward another dawn, knowing only that as long as one of them remained, the fight would never be over. And far below, the waves carried the faint reflection of their passage, 4 dark silhouettes cutting across the brilliance of the Pacific morning, heading once more into the fire.